Okay, so what you have purchased here is Multistack. You got 3 quads, a total of 283 tons. You can, if you don't have at least 8% calling at a time, then you won't see anything running at all. You'll need at least a heat load on the cool side or the heat side. In the wintertime, you're actually going to be running in cooling. In the summertime, you're going to be running in heating for dehumidification and reheat purposes. In the wintertime, obviously, your central plant that usually feeds this facility is not available. So that's kind of where this fills in. I know you guys have economizers on your air handlers and stuff, but there's still going to be a time where you're going to need the chilled water to fill in when your outdoor enthalpy doesn't meet requirements to bring in and condition your facility. So chilled water, flow alarms, and just stuff like that would have something to do with pumps in the facility, that's going to be an issue until bugs get worked out with the controls usually. If it does that, it's really not the chiller, it's more of a flow to the chiller. It pretty much does its own thing. I lean on that a lot because it happens a lot. So a lot of this, a lot of the other stuff I need to go over really you'd be better off, more beneficial at the chiller, going through the program and letting you know. As far as maintenance goes, they've deleted the filters. In the unit locally, you have like sock filters in line with the whole chilled water loop. So everything else pretty much as far as your water guidelines and filtration and all that stuff is really included in the IOM.
Yeah.
No,
Make sure everybody knows. Does everybody know why we have a multi-stack chiller? Why we have a chiller in this building? Do we know why that's there? Anybody have? Because you have campus chilled water. Does that puzzle you on why we have a chiller here?
Most of it's because of the shoulder type areas when we're
right.
Cooling's not available. And,
that's right.
Yeah.
Yeah. So this chiller. So when you have campus chilled water available to the building, this chiller is a heater. Okay. So think of this chiller as a heat recovery machine anytime you have campus chilled water available. So this chiller is going to produce 130 degree water off of its condenser, right? And that 130 degree water is to be used for the heating loop in the summertime. The heating loop is there so that you can actually not have to run a boiler. You're going to run the chiller. It's going to give you 130 degree water. The byproduct of the chiller is then going to be cooling. So you're going to get 45 degree water off of the chiller, and it's there to supplement the campus chilled water system. Okay, so that's the real intent of this chiller. So anytime campus chilled water is available, it's a heater for your dehumidification loop, your heating loop, byproducts chilled water. Anytime campus chilled water is not available, then the chiller is a chiller. Okay. So you're going to run it as a chiller when the campus chilled water is not available. So in those times in November or December or February, when you have a spike in temperature outside for a couple days where you can't use free outside air but you actually need cooling, but you don't have campus chilled water available, then this is your chiller. This is your chilled water for helping to cool the building back down. So just think of it that way. It's a heater first whenever you have campus chilled water, and it's a chiller second when you don't have campus chilled water.
So you have a minimum flow set up for in that condition when we're summertime now, we're cooling with plant water.
Yeah.
Is there a minimum?
Yeah, and it's listed right here, chiller minimum flow, right there, Stuart, down right there, is one up, is 226 GPM.
Okay.
Yeah.
And at the times it's not being used for heating, then we have a heat exchanger for our heating water? Or
Yeah, when it's not being used for heating and you have campus chilled water available, it should be idle. It should just be idle. It's gonna come on based upon the need for heat.
So it's actually gonna help our reheat, so that exchanger.
Perfect. That's the whole intent of it, is for it's for your reheat system, so that you're not. So I think what you're so maybe you don't use boilers, maybe you use steam to
We
hot
use our
water.
steam in a converter.
Yeah. So this would be your first call for heat. You would want to use this first before you use your converted steam to hot water. Okay.
We lead with this, yeah.
Yeah, you want to lead with this.
Right.
Because it's more efficient, more energy efficient to run this, right? And use electricity to go ahead and make this hot water with a byproduct of chilled water than it is to be running your steam to hot water conversion package. So I just wanted to just frame it up for you on why it's there and the intent, because I know you probably don't have, may not have any of these on campus, I'm not really sure. But with that, then Stuart can then, you know, what we want to do is, and he's really good at going through the control panel and showing you how to work the setups and the PM side of things, you know, for what you need to look for. Does that make sense?
Okay. This is your master, and these are all chiller module controllers. Obviously, this master is mounted on module 1, but it's not the actual controller of the compressors. This controls the compressors. This also gives alarms for everything. Even though you'll see an alarm on each module, you still have to reset it from the front end, which is the master. The chiller can run in manual mode should the controls fail. You just switch this over to manual, go into a manual setup in your chiller controller, and set the set points you want. It could be different than what you're actually running the building at. So right now, it looks like we have an alarm on the chiller. And this is something that a lot of guys don't know. To get to your alarms, to clear the alarms, you hit the alarm button, lights up, and you can see what your alarms are. You could have 1 or 2 alarms at a time. Looks like you've got high pressure on this one, high pressure again. Usually resorts to a flow issue because you don't have enough water flow to cool down the water, so it trips on high head pressure. To reset your alarm, you would have to scroll all the way to the very bottom until you see this clear alarm, and then it will tell you what to do. You hit the enter button. This is your enter button, even though it kind of looks like a back button. This is more your back button here, and that will clear your alarm as long as it's not a manual reset. If you have a manual reset, like it's probably the manual reset on this one because it won't reset. Your high pressure switch is inside the module here, and it requires you have to push a button to reset it.
So with your point, it's probably a flow.
Yes, it's always.
The sequence probably isn't quite worked out yet, so it probably lost flow, which caused it to go on off on high it won't because we're not running condenser water pump.
Right. Most of the problems that you do have with most chillers is water flow. And you just need to know how to get in and reset. Once your problem's corrected, obviously. Sometimes you have a crossover problem and it just needs to be reset every so often or whatever, but that's usually what we have with most of the chillers. So once they get the bugs worked out, then that becomes very minimal.
I'm going to see if we can get, I'm going to go over here and see if we can get flow
Uh,
going, Stuart. I'm going to see if we get flow going so we can clear that along.
Well, we're gonna have to reset.
Oh.
It's flowing because we still have modules running now.
Yeah. So you got to go ahead.
Problem is it happened. Once it happens, it
We need
trips.
to show them how to reset that switch.
Right. Yep. So, okay. Other things in the master, you can see everything on any module in here. You can see it from this controller. That's not the easiest way to see it. You can come over to these controllers and see just as much on itself a lot quicker. If you know which module it is, you can just open up that door and go on down through and reset it. This chiller is kind of like most chillers as far as refrigerant flow goes. It's water cooled on both sides. Your metering device is an electronic expansion valve, which is very accurate on these. I'm impressed. So as far as the high pressure switch, we'll have to get into a module here and find out which one it is. Circuit A, Circuit B, both. Looks like the first two modules have tripped on high head pressure. This is your controls for each module. 4 compressors, 4 contactors, 4 breakers. If you see one that's tripped on pressure ratio, that means maybe the breaker's tripped on it and the compressor doesn't run, so it doesn't have a good compression ratio. That's usually one of those. Each module has its own phase monitor. You'll see that come across as PPM and you'll be like, what's PPM? It has nothing to do with water. It's phase monitor, power phase monitor. Yes, yeah, you've got one on each circuit. You got 2 circuits per module, and it'll stage that to keep you out of your low pressure conditions. Instead of running 2 on one circuit, you can spread it out a little bit, and it actually runs more efficiently that way, and it stays out of the danger zone. And each module has the exact same setup going down through here. On the back side of the chiller,